In this part of Unit 7, we're going to talk about something called the triangle proportionality theorem. Let me highlight that for you. So the triangle proportionality theorem, okay, basically it states that we're going to use parallel lines within a triangle to be able to break it into proportional pieces. And so as a warm-up, it reminds us of our parallel lines and transversals, where if we have two parallel lines and we cut those parallel lines with a transversal, we get angle combinations that we use to color code. You might remember we made our checkerboard patterns all the time, right? And same color, same size. So if we make our checkerboard pattern, we get our angle combinations, our alternating and our same side or consecutives, right? And things like that. So this is just a reminder of which angles should be the same. And remember, I don't really mind if you don't remember the names of all the combinations, but remember, if you color code, remember, yellow, blue, yellow, blue, yellow, blue, yellow, blue, right, and go around your picture, you will know which angles should be the same. So which angles are the same as 1? Well, anything that's in yellow is the same as 1, okay? So this is kind of an idea that will lead us to our triangle proportionality theorem. So let's look at an example for the triangle proportionality theorem. Okay, so basically the triangle proportionality theorem states that if you have these parallel lines, so we have these parallel lines going on here, right? If you have these parallel lines in a triangle, then it breaks pieces into proportional pieces. So on the left, this fraction made by the first and the second piece will be proportional to or equal to the fraction created by the two pieces on the other side. Okay, so piece 1 over piece 2 will reduce to the same fraction as piece 3 over piece 4. Okay, and so this makes it really easy to find missing pieces of triangles. Okay, so let's look at an example. So here, technically, we have two triangles, right? To see that we do clearly have our two parallel lines here. Okay, so these two pieces, if I did the 1, 2, 3, 4s, right? The top piece being 1, bottom 2, top 3, bottom 4, right? Top and bottom pieces. So if I make a fraction, 12 over 14, that will be proportional to the pieces from the other side. So top over bottom, top over bottom. Cross multiply, and I figure out that my missing x should be 35 over 2 or 17.5, right? Okay, so that's as hard as this gets. So we're just going to keep doing another example of that. Again, our top piece is here by the point. So we're going to have our pieces 1, 2, 3, 4. So top over bottom. So top x over bottom 7, x over 7. Top 21 over bottom 6. Cross multiply and figure out your missing piece. Again, top is going to be where the point is, even if we've rotated the picture. Okay, so 1, 2, 3, 4. I know we have expressions here. That does not change what we're doing. So top over bottom, 21 over 6, top over bottom, cross multiply, and solve. Okay, so the only part you want to be careful with is naming your top and your bottom and getting your pieces in the right order. So top number over bottom, top over bottom. So again, I always make the top piece where the point is. So top over bottom, top over bottom. Cross multiply, solve. And that's it for triangle proportionality theorem.